Welcome students, I am Muhammad Naveed and you are watching my YouTube channel. In this video lecture, we are going to prove an important formula for the limit, that is limit x approaches to a, x raised power n minus a raised power n upon x minus a equal to n a raised power n minus 1. To prove this limit, first we use long division method to solve this fraction, that is x raised power n minus a raised power n, and we divide it by x minus a. First we multiply x by x raised power n minus 1 to get x raised power n. We multiply minus a by x raised power n minus 1 and we get minus a x raised power n minus 1. We change sign plus minus, these two terms are cancel out. We rearrange these terms and we get a x raised power n minus 1, and we then take this term down minus a raised power n. We put plus sign here. Now we multiply x by a x raised power n minus 2 to get this term, that is a x raised power n minus 1. Then we multiply minus a by this term and we get minus a square x raised power n minus 2. Again we change sign plus minus, and these two terms are cancel out. We are left with a square x raised power n minus 2 minus a raised power n. Similarly, we put plus sign here and now we multiply x by a square x raised power n minus 3 to get this term, that is a square x raised power n minus 2. We multiply a by this term and we get minus a cube x raised power n minus 3. Again we change sign plus minus, we cancel these two terms and we rearrange these terms and get a cube x raised power n minus 1, and again we take this term down minus a raised power n. As value of n is not given, so this process continues until we get a remainder equal to 0. From the coefficient, if we follow this sequence, in the first term is in the first term the exponent of x is n minus 1 and exponent of a is 0 here, and then in the second term exponent of a becomes 1 and exponent of x decreases and becomes n minus 2. Similarly, in third terms exponent of a is 2 and exponent of x is n minus 3. So, exponent of x are decreasing and exponents of a are increasing. So, if we continue this process, in the last terms exponent of a becomes a raised power n minus 1 and exponent of x becomes 0. Similarly, for the second last term we can write exponent of a as a raised power n minus 2 and exponent of x is 1. Now, x raised power n minus a raised power n upon x minus a is equal to x raised power n minus 1. We write this quotient here plus a x raised power n minus 2 plus a square x raised power n minus 3 up to so on. Our second last term is a raised power n minus 2 x, and last term is a raised power n minus 1. Now, we apply a limit on both sides. We have to find this limit, that is a limit x approaches to a. Similarly, we apply limit on right hand side, limit x approaches to a. As the expression on the right hand side is a polynomial, and we know that polynomial functions are continuous, that is, for a polynomial function f of x, limit x approaches to a, f of x is equal to f of a. So, we can apply a limit here and we replace, we put x equal to a, and we get our first term is a raised power n minus 1. We just replace x by a minus a into a raised power n minus 2 after applying limit. Third one is a square into a raised power n minus 3 up to so on. This process continues, and our second last term is again a raised power n minus 2 into a, and last term is a raised power n minus 1. So, our first term becomes a raised power n minus 1, second one is a into a raised power n minus 2. So, it again becomes a raised power n minus 1, n minus 2 plus 1 n minus 1. Similarly, n minus 3 plus 2 is n minus 1, a raised power n minus 1 up to so on. Our second last term is a raised power n minus 1, and last term is again a raised power n minus 1. Remember that there are total n terms in this expression. The reason is, as highest power of x is n minus 1, and this exponent decreases and eventually becomes 0. So, there are n terms up to this term, n minus 1 terms up to this term, and 1 term here in which exponent of x is 0. So, there are total n terms. So, there are n terms here. So, we can write it as this is equal to n times a raised power n minus 1, that is limit x approaches to a, x raised power n minus a raised power n upon x minus a is equal to n a raised power n minus 1. I hope you like this video. If you like this video, don't forget to subscribe my YouTube channel. Thank you very much for watching this video lecture.